Alright, so let's leave the Hello World program now. I think we're done with it. And now let's go to a different program, one that actually does computation. This is a converter from Fahrenheit to Celsius. This example comes from the book The C Programming Language by Brian Kernighan and Dennis Ritchie, otherwise known as K&R. So this example, I like it especially because it shows the C language in a more practical sense. That is, how can we use it to solve a sort of real-life problem? So let's get started. First, let's see what is the general idea of this program. The point of the program is to print a Fahrenheit-Celsius conversion table. And like I mentioned, I wrote at the top a command to compile this program. Before we compile it, let's look at the program logic first. This section here defines variables, and these are type int. We see here lower, upper, and step. And after the variable, you're allowed to write a comment, which explains what is the purpose of this variable. So we see here what is the intention of each of these variables. And next we have what's known as a while loop. The purpose of a while loop is to repeat some commands over and over so long as a condition remains true. In this case, the condition says variable far should be less than or equal to upper. So let's work through this logically. Notice that the variable far initially has the value 0, and the variable upper is given the value 300. Therefore, this loop will happen so long as far is less than or equal to 300. And inside the loop, we're going to do a calculation. And the way I've written the calculation may look a little unfamiliar, but it's really nothing special. This is a calculation to convert from Fahrenheit to Celsius. Suppose F is a temperature in Fahrenheit. Then you can convert to Celsius with the formula C equals 5/9 times F minus 32. So I'll write in the comment the typical mathematical way to write this formula. So in the corresponding C command, you may have noticed that I moved the 9 from the beginning to the end of the expression. It turns out this is because we're using integer arithmetic. So this will give us a result that is accurate only to the nearest integer. And next we print the result. Notice this time how we use printf to print the result of our calculation. So last time we used %s to print a string. However, this time we have integers, so the format string is %d, and you can think of it as meaning decimal. \t stands for a tab character, and \n of course is the new line. At the bottom we have something that would look unusual in math class. It says far equals far plus step. And this is an assignment expression. So it means we're taking whatever's on the right hand side and calculating that and then assigning it into what's on the left hand side. So it just means in this case we're just adding a value to far. So in the case of our loop, that's important because the first time through the loop far has the value 0, and then we'll add 20 to it, so now it has the value 20, and the next time we'll add 20 again and it'll become 40, and so on. So the idea is we keep incrementing this value far until finally the condition in the beginning of the while loop is no longer true. And so when far exceeds the value of upper, then this will terminate the while loop. And of course, return 0 means no error code. 0 is the error code. So let's compile and run this program and see how it works in action. So right here, let's copy the compile command and then paste into the command prompt. One other trick to using the command prompt, if you notice it's getting too messy or too cluttered, you can type this command CLS. It means clear screen. And then your terminal window will be cleared out. So it compiled without any problem. Now let's try running the program by typing FAHR, and now here we have the result. And we see the Fahrenheit temperatures from 0 to 300 in a column, and then with the Celsius temperatures in the other column. So the program works as intended, but let's improve it in the following way. Let's add a header to the very top line so that we can write down what these numbers mean, far and Celsius. That is, let's make the first column Fahrenheit and the second column Celsius, like a table would normally be printed. And the other change to make is to stop using integers. Right now we're using integers for our type just to demonstrate this. But the int type is only valid to a specific countable number. So for example, we see one of the results here is -17. But it's not really, it should have a decimal place in there. So how can we fix it? Right now we're using the type int, which means integer. So we should be changing from integers into a floating point type. And in C, the standard floating point type has the keyword double. So it's called double. So you may be wondering why is it double? What's single? Well, in floating point values, you can represent a different level of precision if you use a double precision value. There's single precision value, which is called float, and then there's double precision value. But we're going to use double because it's more precise and we'll get more accurate answers. Alright, so let's save the program and try running it again. Okay, and now we have some kind of error, so let's look at this. Far.c, line 16, format %d expects argument of type int, but argument 2 has type double. So again, sometimes the error messages can be a little bit cryptic, but in this case it's telling us we changed from int to double, but we didn't change our format string. So let's go look at the format string. So remember in printf we used %s to represent a string and %d to represent an int. So now that we're using double, we need to use a different format string. The format string we need in this case is %f. So it gets a little bit confusing, but we'll look later at a reference of how we can keep these things straight. But for now, %s, %d, and %f. Okay, so in this case, we need %f because we're using double. So try it again, and now we have no warnings and no errors. So we're probably having the correct formatting. And now we see with the floating point values. Okay, one more thing to change about this, and maybe it's just me being nitpicky, but I don't like how the decimal points are not lining up right now. If we want to do that, then let's add one more thing to the printf, and that's called a field width. So here's how you do it. So if we go to our format string is %f right now. And if we go before the letter f, we can type a number. The number becomes the field width. Okay, so a field width is just the number of characters that should be reserved for this data item. So if we count how many characters there are, how many is that? 4, 5, 6, 7, 8, 9, 10. So let's make it a field width of 10, and then afterwards we can write decimal point 2. So this means we want a field width of 10, and we want 2 decimal places of precision after the number. So let's try it again and compare the output. Okay, so now this time I think it looks nicer. We have 10 as the field width and 2 as the precision. Okay, suppose we want to increase the 0.2 to 0.4. So let's try it that way. So notice the difference. The field width remains at 10, but the precision has increased to 4. So next order of business is the header. The header should be printed before the loop. So let's go above the loop and add a header. So we want the header to line up with the numbers. So let's use the same field widths, %10, tab, %10. But for the header, we're not using floating point, we'll use strings. So the format becomes %10s, tab, %10s, and new line. Okay, and so what are the strings? One of the strings is, of course, Fahrenheit. So let's type it in. Fahrenheit. I think actually Fahrenheit is a little bit long for our field width. If you look at how many characters it is, I think we might need a slightly wider field width to fit this. So let's change our field width to make it say 12 instead. So let's change them all to say 12. And the other label is Celsius. Okay, and one more line. This is, I want to print out a line with just an underline, so it makes the table look a little bit nicer. And so I'll just use hyphens to represent this underline. Save and compile, run, and now we have a result. So you see the header at the beginning, Fahrenheit, Celsius, and then the corresponding temperatures. Alright, now let me describe one more change that I would like to make. I probably won't have time to do it in this video, but let's see what is to be changed right now. If you're learning C and you want to try this on your own, then it's a good way to learn the language. So notice what we've done here. We've defined values in the program 0, 20, 300, 0, 320. And these correspond to lower, upper, and step. But rather than fix values in the program, we should allow the user to choose a value when he runs the program. So what we'd like to do is do like in the hello program and make these numbers 0, 320 command line arguments. So then I can type whatever numbers I like and get the table. So that way later if I want a different table, I can type in different numbers, and each time I type in a different number, then the program will just figure out what table I want and give me the correct table. Okay, so that wraps up this tutorial. This is the end of part 2 continuation. Stay tuned for part 3.